Hi all, welcome to the video. In this video, we are going to talk about horizontal pod autoscaler in GKE. So HPA basically help us to automatically adjust the number of pods in response to the workload, CPU or memory consumption. So suppose if CPU will get increased inside your pod, so it will add more replicas, more pods, and if it goes down, it will remove the pods. So basically, it will just help us to adjust the number of pods like up and down, how much pods we need when traffic increase or when how much pods we need when traffic decrease. So with the HPA, we can define all these configuration. In GKE cluster, with the help of like node auto provisioning, you can also add new nodes automatically or new node pools automatically to scale the number of nodes in the cluster based on the change in the number of pods. So it can be possible like you have enabled the HPA, but there is no more nodes available in the cluster to schedule those pods. So you can use node auto provisioning. So basically, it will add new node pools and also it can increase the number of nodes in a specific node pool so that your pods can be scheduled on that. And it is very useful when you need to handle more traffic or reduce the unused resources. And it is HPA basically for stateless app like web front ends, your APIs, microservices that can scale out easily and you just need to add more pods. So why we use or why to use horizontal pod auto scaling? So it is basically for uncertain workloads. So you may not know in advance how much CPU or memory your app needs at different traffic levels. So HPA will adapt this dynamically. You have to just define this. This is the minimum and a maximum number of replicas you need, and according to the traffic levels, it will adjust that the number of replicas. And also, it is help on cost efficiency. So you only pay for extra pods and nodes if you are using auto scaling when it is enabled. When demand increases, so when the demand increase, it will add the new pods, and when the demand decrease, it will remove the extra pods. When the demand increase, when it will add the new pods, it will also add the new nodes because if your cluster auto scaling is enabled, so you will pay for the nodes when you are using the extra pods. When the pods are no more in use, it will delete those pods and the nodes will also be deleted. So you will save the money on the nodes parts also. You don't need to always make like 10-20 nodes in advance even when there is no traffic. And it is also reliable, like you can prevent under provisioning. You can define like I want this number of pods always running, and you can also prevent over provisioning. So like you don't need to run too many pods even when there is no more traffic in your application like in night or in early morning. And it also supports like flexibility, like it supports resource based metrics, like you can use CPU or memory to come on a decision like when to scale or when to scale down. You can use custom metrics like requests per second. You can even use external metrics like PubSub backlog or data flow queue size. So how HPA works? So it will run a control loop in the Kubernetes. First of all, it will measure, it will periodically fetches metrics like CPU, memory, or custom or any external metrics which you have defined, and it will compare against the target threshold. So maybe you have defined as 70% of CPU. If your application goes beyond 70% of your CPU, so it must scale up. So it will just compare against those thresholds and decide. It will then compute a recommended replica count. So it will, based on this evaluation, it will decide what to need to do. I need to increase that replica or down the replica or no need to take any action? And based on that, it will scale the deployment, like act scale that is deployment, stateful setup or down by adjusting the spec dot replicas in your deployment. So there are some best practices. So basically, always use resource or request limits. So HPA cannot calculate CPU percentage without them. So always set like how much CPU request you want and limits. Or and also use cluster autoscaler with HPA. So when the number of pods increase, so it can add new nodes also. And start with CPU based scaling. So once you are comfortable with it, you can add more custom or external metrics so you can understand your workload better, and you can set sensible minimum and maximum replicas and watch your metrics carefully so that you can monitor it like carefully and define your thresholds, like whether to increase the threshold or increase the threshold based on your traffic or your metrics. And there are two HPA API version as of now. So old one is autoscaling slash V1. So it is very oldest and it is still supported. And it can only autoscale based on the CPU utilization. It doesn't support any other than that. And now the latest version in the autoscaling version V2. And if you are using an older cluster, you can use V2 beta 2. and it is now recommended for all the new HPA. It can help you to autoscale based on CPU, memory, or you can even use multiple metrics at once only. Like you can create a combination of metrics, and even you can use custom or external metrics also. So there are some limitations of this also. So don't use HPA and VPA. VPA is basically virtual pod autoscaler. We will see in next part on the same workload. So they can conflict. Like in HPA, it will want to increase the pod count, like adding more replicas, but VPA will what will happen? It will try to change the pod size. It will increase the machine type, you can say. It will add new resources. Like if you are using 500 of CPU, it can ask you to increase up to 800 of CPU. And apply HPO on deployment, not replica set. Always use it on the deployment part. It is not good to put on a replica set because it can be changed anytime. New replica set can be created and your HPA will not work. HPA cannot scale daemon set because they are fixed. One pod per node, as we know. All and metrics are exposed on Kubernetes sources. Matrix name cannot include uppercase or this. So if you are using some custom matrix or anything, just make sure you are understanding this, like don't include uppercase or the forward slash. And if any configured metric is not available anytime, so HPA will not scale down, but it can scale up. So these are some basic theory about HPA. Now let's go to console and use HPA in our cluster and see what are the options we have. So I have created my cluster. So let's go to my CLI, Cloud Shell. If I do ls, I have some files. If I do cat deploy.yaml, it is a basically some simple deployment file which is running a image from like HP example. It is a public image and it is using resources like request 100, memory 128 MI, and there are some limits. So this is a very simple thing. Let me apply this kubectl apply -f deploy.yaml, and it is going to create one single pod, and after that I am going to create a service also so that I can send traffic to that service. If I do ls scat service.yaml, it is a simple service. It is just using it will. So this deployment will run behind the service. So let me apply this also. So it has been created. Now if I run kubectl get pods, and let's see our pod is running or not. It is running single pod. So now let's go here to the console, and if you click on workloads, you will find the same workload running here also. That is CPU demo. That is which we have created just now, CPU demo one. And if you can go inside, you will find all the details about this, like the pod name, like this is the pod name XZFGB. The same is here also, XZFGB. And from here you can also enable the like auto scale, horizontal pod scaling. Here's the option also. You can enable from here also. Even you can enable from the console also, means CLI also. So I have a that file also. So if I do hp.yaml, you can see I'm using auto scaling version 2. It is the latest version and it is recommended one. And here I am targeting my deployment, which is CPU hyphen demo. And I'm saying I want minimum 1 replicas, maximum 10 replicas. Resource I want like CPU for my for like kind of type of resource is CPU, and utilization is average 50. So average utilization is 50. So if my pod go above 50% of CPU utilization, so my HPA will start adding the new pods. You can create from here also. If you click on configure, you can define the same thing here, like I want 1 and 10, and here I can define the CPU. You have multiple option: memory, container CPU, container memory. You can define custom metrics also. If your application use custom metrics, you can even define external metrics also. So, and here I can define like 50%. You can use unit also, like 50 CPU or 50 MCPU, that you can also define. You can add multiple metrics also. We will see that also. Let's do from our YAML file, because it is kind of declarative one and we want that everything will be in proper stage so we know what is happening. So if I do kubectl get HPA, so it will show all the things. Like as of now it is showing target CPU unknown. It will update in a minute or two. Any minimum is 1, maximum is 10, replicas is 0. It will update it to 1. So 1 replica is running as of now. Minimum is also 1 and maximum can be go to 10. And if I come back here and just click on refresh, I will see the same here also. Under horizontal pod autoscaler, you can see okay, it is showing. And if I click, you can see the same configuration is here also. 50, target 20%, all that information is available here. Now what we can do, we can send some traffic on this so that we can say check whether it is scaling or not. Before I send the traffic, let me open a new session also and just run kubectl get hb hyphen w. So watch. So we'll kept on watching what is happening when we start sending some like traffic on it. So I'm going to run a like our new pod in which it will use a busybox image, and from here I will log in into it and send the traffic to my pod. So it is creating the pod, and we can see I'm logged into the pod. This is the command I'm running while true. Do we get, it will kept on sending traffic we get to my CPU demo. So CPU demo basically it is my if you remember my service name also. Click on this, so it will say okay, okay, and once it is start sending traffic, we can see from here also. Soon it the load will start getting increased on this, and it will kept on scaling of the replicas also. So in a minute or two, it will start showing what is happening. As of now, there is 0% of CPU, minimum one replica is there, 10 maximum, and one replica is running, and age is about 60 seconds. You can see now, suddenly traffic has, or we can say load is 200%, and we can see replicas now 4, and it will kept on increasing replicas until the load come under 50%. But if after 10 replicas, it will not add any new replicas. It will just stop at the 10 number. See now load is coming back to 80% after the new replicas are there to receive the traffic. As of now, the 6 replicas are running, but it is still above 50%. So I think it will kept on adding the new replicas. So as of now, we can see the traffic has been stopped under 50%. So replicas count has been stopped. As of now, it is not increasing the replicas. So like this, it can increase or decrease the replicas count. And if we come here also and just refresh our workloads, we will find the same thing here. You can see the managed spots. Now it has been increased to 6 number, and you can see the timing also. First one started at 7:46 p.m. Now the time is 7:51. So it is kept on adding the new replicas as per the load. Like this we can define. Now let me stop the traffic. So we don't want any more traffic. Let me exit this from this pod, and we will see like once the traffic is gone, and it will start removing the replicas also. It will make the replica count to 1 again, but it will take some time because it will do I think wait for up to 5 minutes before taking this action. So we can wait or we can just move to another demo. In this we can do more things also. So it will take up to 5 minutes. So let's stop this. It will delete, remove the replicas after some time. Or what we can do, let me read this deployment. Deleted my deployment and all the things. Now do more things. Let's go to multiple replica metrics, and here also I have the same thing. Let me do cat deploy dot YAML. Here what we are doing, we are running the same one deployment, one replicas, and we are running a container in which we are using some stress ng on startup so that we can see more things. Like it is kind of a load to send more load so that we can see how it works. Let me apply this also, hyphen f deploy dot YAML, and it will create one pod. Now what we can do, we can go here also and just click on workloads, and in the workloads also you can see dual metric demo. We can create like our horizontal pod scaling. From here also we can define like I want maximum 5 replicas. CPU can be like 70%, and you can add one more metric. You can say I want a memory metric also, and for memory you can define like 60% of total memory if reached. You can define in bytes, gigabyte, megabyte, gigabytes, all options we have, and just click on configure. So from here also you can define the same thing, and if you come back and just run kubectl get HPA, we will find the same configuration here also. You can see CPU 70%, memory 60%. As of now, it will show unknown value because it is just like getting the metrics from our pod. This deployment will automatically add new pods because this configuration automatically start using some NP like stress on its own, so that if we run cube get HPA, we can see new pods are already being added. We can see 5 replicas already being there, and you can see CPU is 159% and memory is 22%. Like this, it will automatically running. And if we come here also and just click on refresh button, even we don't have to send the load, the image and the commands which I have mentioned in that our configuration. It is enough to create the load on the on the pod, and so that it can add more pods. We can see 5 pods are running. And if sometime you feel like we need to add more pods, you can just come on here and come on here on actions auto scale, and you can click on horizontal pod scaling. You can define the number of pods from here also. Like let me define 6 as of now. 7, let's go with 7. And if you click on 7, and if you just refresh it, you will see soon it will add new pods also. If you run cubes, it will get HPA. You can see it is already running at a 7.1. You can add like edit configuration from your YAML file also and reassign the YAML. You can do multiple things. Now let's delete this also, and let's do one more thing. Delete deployment dual metric demo. And so now I'm in my one more deployment file I have. If I do cat deploy.yaml, and we can see in this what I'm doing, I have a I have using two containers. One is for primary container. This is my primary container in which I'm running Ubuntu latest and all that. And I have a sidecar container which is a busy box. And this is using 100 of CPU and 150 MI of memory, and this is asking for 100 and 100 of CPU and memory. So basically what will happen if you are in two containers, it can be possible that this second container is no, like not using much resources, and this container is using all the resources. But because of the two containers, when you define the HP on the pod level, it will take the average of both the containers. Maybe one container is on 100%, another container on 0%. So it can make an average of 50%. So your pod will not scale up. So what you can do, even you can define which specific container you want to scale up. So we will do that in this part. Let me define deploy.yaml, and this has been done. Now if I go back to my workloads, and if I go inside this sidecar demo, and if we can try to configure our horizontal pod autoscaler, and if you come here, you can choose container CPU, and you can find the which container you want to use. So you can use log sidecar. So sidecar is basically if you want to download some files, so very basic one. And worker container in which all the configuration or your image is running, main image is running, main configuration. So I will choose this container, and I will say if 50% of CPU, then like scale up the pod. Like this you can do also. So if we come back and do kubectl get HPA, so we can see it will uh, show the site name this, and this is my reference. This is my like deployment name sidecar demo, and this is it will do the CPU and 1 3 and 0 as of now. So this is my HPA, and again it is scaling up because of that configuration we have set in our image, and we can see now it has running 3 pods successfully, and all the pods have 2 containers running, but it is scaling based on only one single container. Like this you can define multiple things. Even if we come back here and let's go to auto scale part and click on horizontal pod auto scaling, you can define more metrics here. Like you if you have a metric of like any custom metric, you can define like from where the metric will come, Kubernetes pod, node, any other object is there. You can define all the things. So I don't have any custom metric as of now to explain you. You can define external metrics also. If metrics is coming from some, suppose from PubSub, you can define that also. These are multiple options. It will depends upon your like organization needs or how your application has been built. And for the auto scaling part, this is the only thing you can see inside Google Kubernetes, and you have to take care of all the limitations and things which we have discussed during the PPT. And I will try to cover vertical pod autoscaler. This is a different thing, but I will cover in the next part how to use this also. Yes, basically horizontal pod autoscaler is very easy, only that not much that difficult. Just you have to define the configuration properly, and you have to define the like your how much CPU and memory you want in your pod specification. That is the request part. Once that is all done, you can use horizontal pod autoscaler according to your needs. So that's all from this video. I will cover vertical pod autoscaler in the next part, and we will see more things in the future videos. If you have any suggestions, comment or anything, just comment it down, or I will drop my email ID. You can reach out to me on the email also. And if you have any issues, concerns, we can connect if I know how to solve that. Thank you very much. Bye.